Hey, what's up, guys? We're going to walk through some very simple property line setup and topography setup for a class Revit file. The actual file was sent to me from the Pro Practice class. There's a couple of issues with this. I'm not sure why they did this, but the actual lengths are fine, but this section here is wrong. There are not 100 minutes when it comes to this type of stuff. It should have been less than 60, but it's not. If you input this the way that it is, it will fix itself, but it has a couple of issues. On top of that, there's some of the lines are missing here because this is actually an arc. This is clearly not straight. And then this one, I believe most of this information over here does go to this. This should be about 600 feet long. And this file is just really, really large. So I actually have an old one that I've used in the past. It's super easy to understand. This property line boundary information was given out by a class that I did quite a while ago. But is the best example that I think could be used in order to complete something like this. And at the very end of this video, if you stick around that long, I'll actually try and walk through this. It's probably going to be a massive blooper reel, but we'll see if we can actually get part of this site to behave. I make no promises though. So let's go ahead and jump right into Revit and get started. So I like to use a default template for all of my new projects, unless the professor specifies it needs to be on an architectural template or like a residential or commercial template. I just use the default. It's set up super easy. There's very little extra nonsense. So I'm going to go ahead and open up the default, and then I'm going to go into the site. Most of this stuff actually needs to be done on the site plan, not on level 1. So I'm going to import both of my PDF files, and they are hidden in a really funny spot. And I know you guys can see it, but we're going to go ahead and ignore that. So the first file I'm going to load in is my topography, which is going to come second. So we got that loaded in, and then I'm going to load in my property lines. And the only reason I'm loading in my property lines is so I don't have to bounce back and forth on looking at a PDF and then looking at Revit. So once we have those both kind of loaded in, we're going to go into massing in site up at the top, go over to property lines, and I'm going to show you both ways of doing it, because you can do it by entering the distances and bearings, or azimuth if that's what your site information is giving you, or by sketching. So we'll do it by distance and bearings first, because by sketching takes significantly longer and doesn't always work correctly. Again, another blooper reel. So as you can see on this particular site, there's only 4 sides. So I'm going to go ahead and add all 4 sides. With this file, you would need to count where or how many of these measurements, these little blocked out ones, are. So for like this side, you'd have 2, 3, 4, and then 5, 6, 7 in total technically. And even this is slightly arcing. So yeah, but again, we're just going to ignore this file for now, and we'll mess with that at the end. So going back into Revit, my professor actually did some arrows just to give you the basic concept of how to do property lines. So when you're doing property lines, it's like you're walking in a circle around the site. Whether you're going clockwise or counterclockwise, it doesn't matter. You just have to pay attention to which way the line is going. So we're going to start off with number 1. We're going to start here in this corner at the very bottom, and we're going to come to the right. So we're going to go counterclockwise with this. We could go the other direction, but if you go the other direction, if you wanted to go clockwise, you would need to change out the south for a north. East would stay the same. This would change north to east, and so on and so forth. So you'd have to switch some things around. Instead, we're just going to do it this way. So we're going to start with the distance, and these are set as decimal rather than the regular feet, inches that we're used to in the imperial system. Input it the way that you see it. If you try and put a space in there, it's going to change it and it's going to be gnarly. So just leave it alone. This is going to the north, meaning, meaning that when you start off in this corner, if you look at this line, it is tilted slightly to the north and you are walking east. So we're going to keep it as north, and then it's going to be 86 degrees, 47 minutes, 54 seconds, easterly, and we're going to leave that alone. Going to the next one, 130.96, still heading north, and this time it's going to be 4 degrees, 10 minutes, 9 seconds. And again, still going to the east. Now we're going to change it up, 106.13. Got that in there. This is actually heading to the south. And it's going to be 85 degrees, 16 minutes, 10 seconds to the west, because we're now walking to the left, which is west. This one is 127.35 to the south, 6 degrees, 59 minutes, 20 seconds. Oops, there we go. And yeah, as you can tell, if you type it in the wrong zone, it's okay. It'll fix. You can easily fix it. And this is heading to the east because this is coming back towards it. Now this last bearing, distance and bearing line, I could have just not done and just clicked on add to close. But since I have this information already set up, there's no reason that I can't just input it and make sure that it matches exactly what was on the plan that was given me. This is probably better, although this can work if you just don't have this information or you're not sure or it's not fully closing. Because on occasion, sometimes your lines just don't match up all the way and it'll tell you at the end. So I'm going to hit OK. And I'm going to put this in the middle. I am going to hide these little things because I don't need them. This piece, I'm going to move to the corner and then I'm going to go ahead and hide it because we're not actually messing with this. This is just the base for the property information. So let me put that in the corner. I like to put it in the actual corner if it'll decide that it wants to snap where I need it. There it is. And then re-highlight it, and I'm going to go ahead and hide that category. So that is the first way. So now we have this all set up. You can move this around, all that good stuff. So the second way, which in my opinion is the long way, and I don't necessarily like doing it this way, but it happens. As you can tell, the north arrow also would be tilted on plan when you actually set this up. Your true north is the way that it is now. Your project would actually be this other line that's rotated 3.2017 degrees to the left. So, but we're going to ignore that. We don't need that information for this. So we'll go into, oops, here, that way I can actually see this property line, and we're going to sketch it. So we're going to start in the corner, and we know that this line is 79 feet, 88. Okay. First line is in. That's going to be our corner. And we're going to grab this little joker from right here. Bloop. Hold on. I'm going to do this slightly different. I'm going to put just a control line. This is straight north. I'm going to drag this down. Again, I do not advise doing this if you don't have to, because this can get super messy really, really fast. And my mouse is set to be ridiculous right now. So I'm actually going to slightly cheat. Go into angle. Come here. This is right at 90, but as you can see, we need 86.7983. So I'm going to come in here. I'm going to select that, 86.7983. Okay, that one's in. Control lines are your best friend with some of this. So I'm going to come over 130.96. And let's go ahead and set the angle. Okay, we're going to grab this line. And actually, I think we might be able to rotate this without it being dumb. So if I come straight up, we're going to come out 16.92. Except for, that's not right, is it? It's really not, because I went the wrong direction. Again, this is why I don't do it this way anymore if I have the bearing information, because it's literally not worth it. And I actually typed that wrong anyways. So it's 4.1692 degrees. Then we're going to come up to the top. Bloop, 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 come across. And this is 106.13. Escape out. Okay, this one. And I'm going to put another control line coming south. We're going to put the angle in there because, you know, why would it not be 90 degrees? Sights are never straight on. So this one's going to be 85.269 or no, 0.5269. Oh, oh, that's painful. I was right the first time. It's 85.269. Okay, there you go. This control line can now go way away. And since we have all of that, you can take this last one, grab it in the corner, snap it to the bottom if my mouse wants to act right, and hit OK. And then if I actually move this, I'm going to laugh if this doesn't fully line up. And that is why. That is why I do not do it this way. It almost never fully lines up. If I spent some more time doing this, it probably would. But just quick example, you can do it both ways. I suggest if you have this information, distance and bearing information, that you use it. It is more accurate and it's actually technically faster than trying to get all these angles in there and do all of that mess. So since we now have all of our property line in, we're going to go ahead and move on to doing some basic topography. So first thing I'm going to do is go ahead and delete that. I don't need it. Double check, make sure. Okay, cool. Now on the one that was sent out, it has the same information. These contour lines, these big puppies, are what you need. They're the information that you need. And you want your lines, when you put it into Revit, to actually kind of go where these are. It is not the easiest thing. If you zoom around, hopefully somewhere, it actually has the information for how far apart these grid spaces were. So let's go up. Yeah. I believe these are probably 10 foot apart. Probably actually less than that. These might be 2-footers. Because these contour lines are 10, so I would guess those are probably 2-ish. But we're not going to worry too much about that because the topography that I'm going to use is super simple, and then you could use the same technique to do it on this one. So going back into this, we're going to go into our Revit file again. I'm going to go ahead and scale this so that it kind of matches. This is very, very large. So with scaling it, I'm just going to grab it in the corner, try and line this thing up. I'm actually going to shrink it first. That way I don't really have to worry about this. Okay. Follow your actual property line. It sounds silly, but it'll actually help you in the long run. So grab that, and then we're going to put it in the corner. So this is just a rough sketch that the professor in the class that I was taking did. But it's a really great example of it. So we're going to start with the 4 corners because we know exactly what those are. And then I'll show you just quickly how I got some of the information towards the end. So I'm actually going to pin this. That way I don't accidentally delete it. To start doing the topography, we're going to go into Massing and Site Topo Service. And we're going to do it by placing points. If you have a CAD file, which I hope that you do at some point, and they don't just give you these random maps, the CAD file you would do from Create from Import. And I will show you what that kind of looks like because I think I have one that would work out. I have a contour line set somewhere. I just have to find it. So to start off, we're at 101 feet. So go up to your elevation. You're going to change this to 101. And then you're going to grab it and you're going to put it on your corner. The other corner is 99 space 6. And grab the corner. Come down here. 97 6. Grab the corner. 96 6. Grab the corner. Now we have our surface. And as you can see from some of these lines where they're poking out, we're pretty stinking close. We're really, really close. So come down to this base and go into wireframe. Oh, Jesus. I hate when this happens. Bring in that other file because why not? Make life really hard on myself. There we go. I'm going to shrinky dink this down. Boom. There we go. Okay, so we have one that's 99, one that's 100, 98, and 97, and then the 96.6 in the bottom. So these lines are not going to be exact, and you're never going to get them to be exact. It's just not going to happen. But we can get them close because we can see the little pokies on the sides. So we're going to go into and select the actual topography first. Hit edit. We're going to place some points. So let's start off in the top. I like to start with the very, very big numbers first. I know that it's like right about there. And it's right about there. And then there's probably a dip somewhere in there. Next one's going to be 99. Sorry. I got a bug stuck in my throat today. 99. But we know that it's not flat. So we're going to do just a couple of little weird things. We're going to bump it out. Bring it up. There we go. Super fun. Woo! And then 98. Come down here at the bottom. The 98 also like bumps over here. So we're going to bring this down. And then we're going to come up and across. Because why not? Why not make this difficult, right? Topography is naturally difficult. So if you're struggling with it, don't feel bad. Everybody has a problem doing topography, especially when it's done like it's being done right now. Okay. So now we have all of that. I'm going to go ahead and delete these files and we'll throw this into 3D view and see what it looks like. So there's our 3D view. And if I go into shaded, there you go. Now we have very, very basic topography. This site barely came down. When you actually look at it, it was at 101 up in the top corner. And the lowest it goes is 96. So that's not very many feet. It's a relatively flat site, made it very easy to work on the project, cut out all of that stuff. This one, on the other hand, not so easy. So it goes down quite a bit. Your base is 295. Your top end is 380. So you have about a 100-foot drop between this backside and this front side of this site. It's not... This happens, especially in the Los Angeles area. This is extremely common. That's why topography is such a nightmare. Most of the time, you're going to use point files. And let's see real fast if I can actually find one of those to give you an example. There we go. Topo only. Okay. This thing, this file, was huge. See how big it is? It's just massive. There was a lot of topography on this. So I'm actually going to hide the one that we just did. So this is the most current topography file that I had messed with. It is, it's a combination between Rhino and CAD, ArcGIS data. The amount of information that I compiled to make this CAD file was insane. And then I did some pretty basic mesh modeling in Rhino just because Rhino is slightly easier to do mesh with than CAD. So let me go ahead and hide this in 3D. So I like to do these CAD files in 3D. So if I go to massing and site, you're going to go to topo again, create from import, select my thing. I don't like doing 0 layer, just the mesh, and hit OK. Let it think, and then hit a checkbox. Literally don't mess with that any more than that. And then unpin this, and delete it. And there's the topography. This, again, this is a really, really huge file. I do not suggest drawing directly on files that are this large. Break apart your site and then draw on just your site and relink in. There is another video that I did prior to this about how to link these files together, especially Revit to Revit files. But that is how you do that. Now, if I guess the last piece that I'll try and do is mess with some of this. It is not going to line up. I'm giving you a warning now. It's not going to line up correctly. It's going to throw a hissy fit. It's going to be really funny. So I'm going to go ahead and go into insert after I get out of the 3D view. We'll go ahead and delete all of that information. Import. Go back into where I hid these tutorial files. And these two files I'm happy to share with you guys. I just have to make adjustments. Bloop. Okay. So this is for a class. If I could crop this, I would, but I'm not going to sit there and mess with it too much. So we have this bottom. Ugh, gross. I'm going to bring this in as a much higher quality. Bump this to 600. It does take longer to load if you change that resolution, but it can actually help you quite a bit. So before we couldn't really see that, now we can. Okay, so first thing that I'm going to do is I'm going to take, not text, model line. Go over the 64 feet, 64, hit enter, escape, escape, grab this, grab that. I'm just scaling this drawing, that way I can at least partially see. And then come across. And there. Okay, now she's scaled. Woohoo! Right? Yay, whoopee. Fantastic. So, trying to do this file, and like I said, I really hope he just gave the property line for this assignment. I'm not in that class. So, let's just go to property line. We're going to go to distance and bearing. This is one of those files that, because it is so large, you're going to have to use the two-screen method. So you can see some of them, and I'll try and move this around just a little bit. Again, this back line, I'm not even going to attempt. I'm just going to go ahead and close it, and then we're going to laugh our way to the bank, because I'll show you how to do some of the topography in this too. So the first line is 53.19. It is heading to the south. And it's going to be 40, 100. Or is that 401? Hold on. Watch. 401 space 00 tab. See, you can't do it that way. Again, I don't know why they set this up this way. So 40 degrees, 100 minutes that don't exist, 00. And this is going to the west. So we're going to change that out as well. Next line, and as you can see, this was 4100. This moved it to 4140, which is what it should have been. Scroll down on my PDF so I can see the next measurement. 39.97. Still going to the south. 4140, because that's the correct one. There we go. Here. I'm going to add these last ones. Okay. Next up, 184.155. Zoom over. This is going to the north. 68.130 west. Okay, last little bits. Scroll up on my PDF so I can actually see the measurements. 104.64. Still going north. 40, 100. This is now going to the east, so I'm going to leave that alone. And then it's 74.01, 4140. Everything stays the same. And I'm going to do an add line to close. Okay. So then take this and move it to the corner. See, it's not completely lining up. At least it's like kind of close. It's just not the best. This is all, yeah, no. And I'm really hoping that he walked through how to actually fix this and understand like what was going on here, because again, this is not how this is done. For the topography, um there's also no topographical points at these. That is also naughty. That's a very naughty no-no. But we'll go ahead and we'll assume that this is probably 400 in the corner. So let's do our topo surface. We're going to do 400 in the corner. Then we're going to go into 390. And just kind of go along the line. It's not going to be 100%. And if I hit checkbox and then go into 3D view, the reason it's not showing is because it's so high up. Go figure, right? Well, you can also change that by doing a VR, not a VV, VR. I'm going to bring this up to 500 feet. Cut plane, also 500 feet, and hit enter. So now you can actually see that insanity. Okay, going to edit surface. And we'll just keep going through the rest of this. So we'll do 380. Grab my line, grab my line, grab my line, grab my line, grab my line. Just where it's kind of sitting at. Doop, doop, doop. Okay. There we go. So that's in. Go to 370. Grab the edge. Come across. Again, you're not going to be 100% with this. It's never going to happen. You can try and get close. It is worth trying to be as accurate as possible, especially for school files. But there you go. And then you would just continue this all the way down. You can start in either corner, grab the property line, and just follow this down. The other way that you can also do this is by going into your model line, grab a spline, and then bring a spline across. Bloop, 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 bloop. Oops, there we go. So you can bring a spline across, or because this one is super, like, insanely straight, just do regular lines coming all the way across and then grab those. This is a long method of doing this. I'm sure that there's other out there that have different ways of completing stuff like this. Every person is kind of different on how they accomplish the end goal, but don't think that you're wrong because you find a new way of doing it. If you do have a better way, send it over to me. I'm happy to look at it, add it to my workflow, and do another video updating if it works a little bit better. So there you go. So then you just have model lines all the way across. It is an absolute nightmare. I am not a fan of that file. But there you go. That is the way that I would set that up and how I would go about actually doing all of these pieces. So I hope you guys found that at least halfway helpful, that it explained kind of how I like to set those files up. Again, if you have the distance and bearing information on your file that is complete and not messed up, use it. Do it that way within Revit. It'll save you a bunch of time and it'll actually help you in the long run. Topography, one line at a time, not overly accurate. If you're doing it this way, you're never going to be 100% accurate. Just know that. Don't feel bad. And yeah, hope you guys have a good rest of your day. I will catch you on the next one.